Hello, hello everyone. All right. Hello, hello everyone. There's a little bit of a delay, so I'm just trying to see how long. There we go. Okay, so I'm going to get started. I will also have this posted to Google Classroom, so if you weren't able to join us live, you can still see what we're doing. So as you're coming on, just comment so I know you're here. If you're, watching at a later time, you can comment in Classroom. Okay? So hopefully what you've done so far is watch lessons 3 and 4, and then I'm just going to go over the homework answers to those. Yes, let's get our math on, Stephen. And then we will, and then just let me know if you have any questions. So, hi, well, we're not doing anything new. I just wanted to come on just to kind of talk about the unit circle a little bit. And go over any questions you had on lesson 3, lesson 4. I know some of you haven't taken the quizzes questions from lessons 1 through 4 yet. Hi, Mrs. Smith. So that's kind of what I wanted to go over today, and just let me know if you have any questions. So I'm gonna switch my screen. Hopefully this will work out. Now you should see the screen, our unit circle, okay? And let me see if this will then work too. And then that. Yay. So I'm still trying to figure this out, but I thought it'd be nice if you guys were able to see me, do questions. Dom, how are you doing? How is your recovery? You ready to do some math? So the unit circle is definitely way different. So I wanted to come on and talk about it. I know if any of you watched Mrs. Smith's video that why can't I see you? Can you see me now? That she did a really great explanation of the unit circle. So I just want to go over a couple questions that people had on page 14. So if you're with me in the packet, we can take a look at page 14. Let me know if you want me to zoom in at all. I know the answer key is posted, but just sometimes, hearing the problem done out will be, is a little bit easier. So basically in the first notes, we did this unit circle. If you have access to a printer, it might be nice. I just went on to Google and typed in unit circle. It might be nice to print this out to take a look at it. But basically in class, what we did was we filled in, we did our 30, 60, 90, we did our 45, 45, 90, and then we went ahead and filled in the unit circle for quadrant 1, and then we just kind of talked about how it carries over for quadrant 2 and for quadrant 3, and then for quadrant 4. Okay? So as you can see, all of the coordinates are the same throughout, but it just depends on the quadrant that they're in, what sign they have in front of them. And same idea with your, this is positive, this is positive, this is negative, this is negative. Okay? So some things that you wanted to do for number 14, draw the rotational diagram. So we did that in class, last week. So everyone should be pretty good with that. Remember that if you are unsure of where your negative is or where your degree is, if it's negative or if it's over 360, you could always find that coterminal angle by adding or subtracting 360, figuring out where that terminal ray is, but make sure your diagram is drawn correctly according to the degree. Okay? A couple questions about the coordinate point. So again, 330 degrees, we can go right onto our diagram of our unit circle and grab that point. So if you have it filled out or this right near you, you can use that. But again, on quizzes and tests, not going to be able to have this unit circle out in front of us. So there's a couple important decimals that you want to make sure you know. So first of all, on your graphing calculator, you just want to make sure that you're in degree mode. And then you want to go ahead and type in the cosine of, what did we say, 330 was the first one. So the cosine of 330 gives you this decimal point 866. So you want to really know that radical 3 over 2 is equal to 0.866. So that's going to be one of our special decimals that you're going to want to know is the same thing as radical 3 over 2 because I'm not going to want to see this decimal. I want to see this. So this is cosine and this is sine. Alphabetical order, cosine, sine. So when I type in the sine of 330, it gives me that -1/2 and I could write it. So really we're just doing the coordinate points, whether we're using our calculator or whether we're looking at the unit circle. Okay, some questions about ones like this where it was right on the axis. You can do the same thing with your calculator. Just remember this over here. Here, I'll show you the picture again. You know, if you were to plot this point, it would be 1, 0, 0, 1, 0, negative, or excuse me, -1, 0, and then 0, -1. So those are going to have those nice coordinates of 0, 1, and -1. Other than that, that's that first section. So if there's any questions on the first section, just let me know and I will answer them for you. Moving on to section 2, or question 2, says draw a rotational diagram for each of the following radian angles and then determine the ordered pair that lies on the unit circle. So basically the same idea, except we have our radian measure. So if you have your diagram and you have your 2 pi over 3, you can find 2 pi over 3, you can see what it is, you can see what the coordinates are. But again, what do we do if we don't have that? We're going to go ahead and take our 2 pi, so 2 pi over 3, and then we're going to go ahead and multiply it by 180 over pi, because that's what we did with our conversion. So we all did that together last Friday, and then it's going to give us our 120 degrees, and then we can go ahead and do the cosine of 120 to get -0.5, and we can do the sine of 120 to get our 0.866. So again, that decimal came up again, so we should be able to go ahead and write those coordinate points there. Now another thing you can do is you can change your mode to radian mode and then type the actual radian in. So you can do cosine of 2 pi over 3, cosine of 2 pi over 3, and it will get you your cosine value as well, and then your sine of 2 pi over 3 will get you that same decimal, 0.866. Okay, so a couple different ways you can do it. If you don't like toggling back and forth between your degree and radian, then you can do it that way. If you're fine with that, then you can just use your calculator to get to those answers. Okay, so just be careful on ones like this. So seeing what I did here, I just took the radian, I converted it into a degree, and then I went ahead and added 360 to get to the coterminal ray. So I knew how to draw my rotational diagram, I knew where it ended, and then I still went the appropriate distance and direction, and then put the appropriate coordinate point there. Okay, some people ask me about letter D, so it's the same thing. So -pi over 2. So if you are looking at your unit circle and you know that this is pi over 2 this way, you would just know that the same distance, negative pi over 2, would be down here. So that's where you would want to draw your rotational diagram, and that's where you'd want to identify your coordinate points. Okay, so I don't see any new comments. So let me know if there's any questions on any of those, and then we'll move on to the next piece. Okay. All right. So also at the beginning of the notes, we have to know that the unit circle is this equation right here, x squared plus y squared equals 1. So here we're just verifying that it's true for each below. So it's just a substitution in and a check to make sure that the left side equals the right side. Okay. Number 4, there are other points on the unit circle besides the ones that we've determined in the lesson that are printed on that unit circle. So every point, though, must satisfy this equation or else it's not on the unit circle. So what we want to do is find all the possibilities for other coordinates that with this x or this y value, and what coordinate corresponds with that. So you're going to go ahead and just substitute it in, and then you're going to go ahead and solve it. So you're going to square it, and then you're going to subtract it over. You're going to do in your calculator 1 minus 9 over 25, math enter, and then you're going to square root both sides. So just make sure when you square root both sides, you do get the positive and the negative version. You can't see that. You do get the positive and the negative version of that answer, because remember, if we were to plug it into the y, the negative squaring it would get us the same thing as if we put the positive in and square that as well. Okay? So that's why all these answers are plus and minus, plus and minus. So just be careful for that particular piece. Okay? Now for number 5, this one here says, for each of the following angles, determine the reference angle, state the coordinate on the unit circle for both the angle and the reference angle. And then again, it's going to say, what do you notice about the coordinate pairs? So most of you should have done the appropriate diagram as we've practiced. The reference angle, remember, is this acute angle that's down to the x-axis. So it depends on where you're located. If your terminal ray is in quadrant 2, then you're going to subtract it 180 minus the 150 to get the 30. If it's in quadrant 3, you're going to do 180 minus the 45. The 225 minus the 180 to get to 45. And then if you're in quadrant 4, you're going to do your 360 minus the 300 to get the 60. And then if you are in quadrant 1, it's whatever the ray degree is your reference angle. So then if you were to take your calculator or look on your unit circle, you found that the reference angle and the angle that you were drawing have the same values. Obviously, depending upon all these ones here, the 30, the 45, and the 60, because they are reference angles, if we were to draw them, they'd be in quadrant 1, so that's why all those are positive. But then because 150 is in quadrant 2, the x value is negative. This 225 is in quadrant 3, so both values are negative. And then this 300 is in quadrant 4, so the y value is negative. Okay? So hopefully that clarifies some questions on lesson 3. Any questions you have, and that you feel more prepared to take the that quizzes online. All right? Then we should have watched this video here, reminisced a little bit about our SOHCAHTOA, and understood kind of where we got the opposite. Y sine was equal to y cosine was equal to x. So kind of, we talked about it a little bit before in the previous lesson, but this kind of goes into why that is so. So it's super important to have this written here. So cosine is our x, sine is our y, and then this was just our the most important facts and stuff to remember. So we could use our calculator for all of these, but we should really be knowing what these are, at least the special ones, like they said, on our own. Okay? So just let me know if there's any questions with that. On this next page here, This one, again, it's just knowing that sine is the y value. You grab the y value. It's probably hard to see, so here it is. It was 0.8. This is also something that's really important that's going to get us into the next part of the page is here we have a little diagram ASTC, and we remember that by all students take calculus, okay? There's a couple other little anagrams, but all students take calculus, okay? So what does that mean? Well, it means whatever quadrant we are in, that's how we're going to know whether our answer is going to be positive or negative. So if we're in quadrant 1, our answers, our sine and cosine answers and tangent are going to be positive. Here, S stands for sine, so sine is what's positive here. Over here in the quadrant 3, T for tangent, that's what's positive there, and C for cosine, that's what's positive there. Everybody else is going to be negative. You're going to choose the negative answer in that. So here's what I mean by that. So it says here, just like our x squared plus y squared equals 1, we have our cosine squared plus sine squared equals 1. So this is our Pythagorean identity for any angle theta. So we have an angle A. It has a terminal array that falls in the second quadrant. So immediately when they tell you what quadrant it's in, you have to understand that that's S. Okay, so sine is positive there. So right away when they ask you determine the value of cosine, you automatically know that that answer is going to be negative because sine is only positive in quadrant 2, okay? So you can either think about that right away or you could wait till the end. So just like before on the previous page, you're going to just solve. You're going to, whether you write this as x or whether you keep it as cosine, for the time being, cosine squared, you don't know what that is, plus you're going to substitute in the 3/5 squared, subtract it over, square root both sides, you get the cosine theta is equal to, and remember before we get our positive or negative value, and this is when we actually choose the negative value because we were told we're in the second quadrant, okay? And then for number 6, we have our first quadrant, so we know the answer we should choose would be the positive version of the answer, no matter what, because A stands for all, so cosine, sine, and tangent are all positive in the first quadrant. So they give us a cosine value, we want the sine value, we're using the formula, we're plugging it in, we're subtracting, we're taking the square root of both sides, and this does say simplest radical form, so this one here we needed to do just a little bit of simplifying. And then again, we're choosing the positive value of that versus the negative value that we do get because we're taking the square root of both sides. Okay? So hopefully that was conveyed to you well in that video that you watched. The answers, are already posted, but I'll just go through a couple things here. So remember, we have some special decimals. So here we have the sine of 60. I'm going to remember my mode is not in degree mode. So I'm going to go back. So sine of 60 is that 0.866. So that's our radical 3 over 2. Here we have our cosine of 135. So this right here is another one that we went over in class. I just want to make sure we know it again. So 0.707. So that is going to be that special decimal that we want to remember goes along with radical 2 over 2. So radical 3 over 2, radical 2 over 2 are those special radicals. Again, where are they coming from? They are the radicals that you see on your unit circle. See, there's your radical 3 over 2, there it is again, and there's your radical 2 over 2. And that's the only radicals we have so far for sine and cosine here that we should know the special decimal to. Again, kind of like a calculator question for this one, which one is not equal to sine, figure out what each of these are, which one isn't. This is our terminal array. Again, the sine is the y value, so we pick that one. And I do want to have you take a look at number 5 here. So this one's important. So it says we have a point negative 5, 12. So we actually want to draw that point negative 5, 12. And so we should know that that's going to be in quadrant 2. And then we want to draw a triangle. Now I have the word bow tie over here because you want to draw it like a bow tie, okay? So what I mean by that is when you are finding these points in whatever quadrant, you need to draw your triangles in that bow tie fashion, okay? So if it's in this quadrant, this is the bow tie. okay? If it's in this quadrant, this is the triangle, this is the triangle, this is the triangle. So it's always in the bow tie shape, okay? So that's going to be important. What you don't want to do is draw a triangle that's like this. That's not the triangle that you want to draw. So that's not going to get you your bow tie. So make sure you're good with your bow tie, and we'll practice that more. Okay, so why is that important? Because now we're going to use our Pythagorean theorem. Our a squared plus b squared equals c squared, so we get 13. And then it says, which of the following would represent the cosine? So our angle is always coming out of the origin, which again is why we have our bow tie. And cosine is, again, adjacent over hypotenuse. So adjacent means next to. Hypotenuse is across from your 90-degree angle, so that's 13. So that's adjacent side, -5, divided by hypotenuse side length, 13. So that's why we get choice 3 there. Okay? Thanks, Mrs. Smith. So if you're still, Mrs. Smith just said that if you're a little bit confused on the unit circle and how it was made and what you should know about that, she has some videos on her YouTube channel that you guys can go take a look at if you wanted something extra from what Kirk did, okay? All right, and then the last page here for number 6. Which of the values cannot be the sine of the angle? Well, the radius of our unit circle is 1, so it can't be bigger than 1. All right, for number 7, for an angle drawn, these are kind of my favorite, but it says for an angle drawn in standard position, it's known that the cosine is negative and the sine is positive. So basically, we're going to draw our, anytime it wants the quadrants, all students take calculus. And then you're going to go ahead and read the kind of restrictions that it has. So it is known that cosine is negative, so can't be this quadrant, can't be this quadrant, right? Because cosine is positive here and here. And that it's known that sine is positive. So out of these two quadrants, the only quadrant where sine is still positive in is this quadrant here, which is quadrant 2, so that's your answer. Okay, so it's kind of how you want to do these questions. So if both sine and cosine of an angle are less than 0, so what are they getting at there? They're getting at that it's negative. So if both sine and cosine are negative, it can't be here, it can't be here, and it can't be here, right? So it's got to be quadrant 3. Which of the following has a cosine that's different from sine of 30? We have, again, you can use your calculator. So cosine of each of these, which one doesn't match sine of 30, which is 1/2. Okay? All right, and then getting down to these ones here, when drawn in standard position, an angle has a terminal ray that lies in the second quadrant. So again, here's our second quadrant, so we're drawing that, and whose sine is equal to 9/41. So remember, because they said sine is equal to 9/41, sine in our SOHCAHTOA is opposite over hypotenuse. So we have our opposite, which is 9 over a hypotenuse 41. So 9/41. Find the cosine of the angle. So what we could do is we could use our Pythagorean theorem to find this, and then we know our cosine is adjacent over hypotenuse. You could also use this right here, our equation of our unit circle. So if we're trying to find, it's again basically the same thing. You have a squared plus b squared equals c squared, and so, or x squared plus y squared equals 1 squared. So it does all come out to give you that same answer. So the x is going to be plus or minus 40/41, which should match because this guy was 41, so that means that guy would have been 40. And again, this is super important. At the very, very end, you have to make sure to tell me whether it should be positive or negative. All students take calculus, so negative, cosine is negative in quadrant 2, which is why my answer is negative. Okay? I know there's a couple different ways to get to that answer, but that's what we're looking for, and then you have to look at the sign. What sign should you put on there? And then number 11 here, we have the terminal ray lies in quadrant 4. This was different, I think, than someone said it was different than it was posted on my answer key, possibly. So sorry about that. So let's take a look at this one here. If the terminal ray lies in the fourth quadrant, we have our sign is negative radical 3 over 3. We can put that right into the formula. We can square it, we can subtract it, we can take the square root, and then again we do get the positive and negative version of that answer, plus and minus. However, all students take calculus, and cosine should be positive in quadrant 4. So that's why the answer should be positive radical 6 over 3. Whew. All right. So I just wanted to come on because I know this is kind of way different than what you've done before. You've done a little bit of Pythagorean theorem and SOHCAHTOA, but nothing with the unit circle. So I know it was different. But you guys are used to those Kirk videos, but I thought maybe explaining it to you guys this way would be a little bit better. So just let me know if you have any questions. I'll stay on for another couple minutes. If there's any specific ones you want me to go over, I will go ahead and go over those. Just kind of type them in the comments and let me know if you have any other questions before. I know some of you maybe didn't take the unit, the lesson 1 through 4 quizzes online. So I did extend that until Sunday, I think. It might still on Google Classroom say today, but I think I extended it till Sunday just to make sure everyone was able to log in and get everything and go from there. Okay? So I don't think that there's any questions. Just waiting a little bit. There's a little bit of a delay from when I say stuff to when it actually gets to you guys. So yes, yeah, I think it's pretty cool. Yeah. So like for the reference angle, so if you want like a reference angle of negative 270. So first of all, you want to know where that is on your diagram. So if you're unsure, you can always take your negative 270 and add 360. And it would say 90 degrees. So hopefully we all know where that is. That's right here. Okay? And then so when we draw our rotational diagram, we're going to go this way, right? Because it's negative 270. And then when we think of what that is, we could use our calculator and do like the cosine of, we could do negative 270, the actual question, or we can do cosine of 90, and we still get the same thing, okay? So 0 is going to be our first coordinate, and then when we do the cosine, or excuse me, the sine of negative 270, or the sine of 90, we get positive 1. So no matter what we use, we just want to be careful about our rotational diagrams with that right there. So sometimes the negatives are a little bit tricky. But any other questions? And like, Let me try if I can find. Lesson 3. So if I go back to like lesson 2. Let me see where the reference. I think maybe it's lesson 1. So for the reference angle piece, that is going to be the acute angle that gets you back to your x-axis. So I'll just do like a couple quick diagrams. So if you have an angle in quadrant 1, it's going to be whatever that angle is, say it's 60 degrees, that's the reference angle. Okay, so whatever it is, that's what it is. In quadrant 2, your ray would be here. So let's say that's like, I don't know, 100 degrees. Then this right here is the reference angle. So it's always the acute angle down to your x-axis. So that's 180 right there on your x-axis. So you do 180 minus 100 to get that positive value for your reference angle. When you're in quadrant 3, say this is, I don't know, like 200, and this is 180. So this is your reference angle here, and you're going to do your angle minus 180, which is 20. So 20 would be your reference angle. And this goes for the same. So any reference angle in quadrant 3 that you're looking for, when you draw the ray in this quadrant, you're always going to take that degree and minus it from 180. When it's in quadrant 2, you're always going to take 180 and minus the degree. And then in quadrant 4, if that's where you are, this is your reference angle. Again, it's always the acute little angle getting you back to the x-axis. Now this is at 360. So let's say this is 300 degrees. You're going to do 360 minus 300. So of course you're always going to take the bigger angle minus the smaller angle, but that's what you want to do for that one. Okay? So hopefully that clarifies the reference angles. So in quadrant 1, reference angle is exactly what the angle is. In quadrant 2, you're going to take 180 minus the angle. In quadrant 3, you're going to take the angle minus 180, because quadrant 1 and quadrant 2 both touch on the 180 degree, the x-axis there. So that's why we subtract it from 180 for those two quadrants. And then quadrant 4, the reference angle goes up to 360. So that's where we're going to do 360 minus that degree. Okay? The all students take calculus refers to all of the functions are positive in this quadrant. Sine is positive in this quadrant. Tangent is positive in this quadrant. And cosine is positive in this quadrant. So depending upon what quadrant you're in, that's going to determine your answer. Okay? So say you're looking for, trying to think of one of the ones that we did. So say you're looking for like the cosine in this quadrant 4, you know the answer is going to be positive. So if cosine is the only thing that's positive in quadrant 4, that means sine and tangent are negative. So again, sine and tangent are negative in this quadrant. Sine and cosine are negative values in this quadrant. And cosine and tangent are negative values in this quadrant, and all of them are positive in this one. So sine, cosine, and tangent are all positive. And that just goes back to your unit circle too, Riley. So you have all of these. This is cosine, this is sine. So all of those are positive, all A, in quadrant 1. Over here, your cosine is positive, or excuse me, your cosine is negative. You see all the x values are negative, and all your sine values are positive. Now you're going to learn that sine and cosine together help you get to tangent in the next lesson, number 5. So that'll be more clear about tangent. And then here you see that we have two negatives. Sine is negative and cosine is negative, but tangent's positive. And then over here we have cosine positive, sine negative, and then tangent will be negative. So again, it just goes along with like your coordinates as you're plotting points, as long as you know cosine is x and sine is y. Okay? And so that helps with a couple different things of actually identifying the positive or the negative version to use for your final answer, or like what quadrant an answer could be located in if something's positive or something's negative. So hopefully it's just a little anagram to help you remember all students take calculus, that all is positive, sine is only positive, tangent is only positive, and cosine is only positive. Okay? Does anybody else have any other questions? Perfect. Awesome. So guys, just keep checking the Google Classroom. We will be doing like certain office hours so that you guys can log in and kind of ask your questions and go over it. I'll probably be doing some videos similar to this. Not that you have to go on at the specific time, but we do expect that you, watch the videos. If you have questions, this is where you're going to be able to get those questions answered from the homework pages. Most of you should be still watching the Kirk videos, and then or videos that either myself, Miss Smith, Miss Conway, or Miss Ebers are going to create as the lesson video. Then you try the homework, and then we'll also create a video to go over the homework. So that way you can hopefully get all your questions answered. Like I said, so just watch out for like office hours coming at you, so that way you can kind of log in and go from there. So I don't know, this I think is easier as far as like going over things. Google Meets is really cool, but if there's so many people on at one time, there's going to be just a lot of talking. So we'll kind of do a little bit of both and kind of see what we like. But just let me know if you have any other questions, and you should be set and prepared if you haven't already to take the unit 11A 1 through 4 lesson quizzes. That was assigned. Okay? Again, keep shooting me emails. Let me know if there is any technology problems that you're having. Some people were saying they couldn't get to the Google Slides, but I think they figured that out. So just let me know. Don't worry about it if like in the turn-in, the assignment was late to turn in. Still turn it in. I want that to be a little checklist for you and a checklist for me, so I know who is being active and just completing the assignments and doing the assignments as they should. Okay? I will help you with that, Miss Smith. No problem. All right, so I'm going to go ahead and log off now. Like I said, email me with any questions you have. And then Monday, we're going to get some started on some new stuff. So don't get too far behind. If you didn't finish something or you couldn't get the technology stuff going, just let me know. I'm really flexible with everything, obviously, especially what's going on now. The most important thing is that you guys are staying safe, staying inside. Please make sure that you are, not just hanging out with friends all the time. Try to stay inside as much as possible. Do these face-to-face things with your friends, because, we want to hopefully get over this quicker, than, sooner rather than later. And then we can get back to school and get back to kind of the normalcies that we want to, that and all the fun stuff that happens at the end of the year. So, all right, guys, I'm gonna hop off now, but thank you guys for joining me, those who did, and I will see you later. Okay, bye.